So, example 1. Today, first of all, we are talking about functions. It is IF for interpreting functions, and is basically we're going to dealing with functions. Okay, that's our common core. All right, functions, function notation. So, example 1, y equals x plus 3. So use these input values. So input means let x be these. So let's let x equal these values right here. So really we got y equals negative 2 plus 3, right? Gives me an answer of 1. You okay with that? So then you have y equals negative 1 plus 3. The answer is 2. Right? Just plugging these in for x right there. That's all I'm doing. Y equals a 0 plus 3, which is 3. Plugging the negative 1 in for x. You guys see a pattern yet? Hopefully you see a pattern. Do you see a pattern? What's the next one? 4, 5. Whoops, that's 0. Oh, that's because I must have made a mistake. 3. There's my 4. Y equals 2 plus 3, which is 5, and y equals 3 plus 3 equals 6. Okay, is this a function?
Yes.
It is a function. Every single x value has a unique y value, right? If we graph this, if we graphed it, just looks something like this, okay? If we graph it, it looks something like this. We know it 1, 2, 3, right? Okay, it looks something like this. Now, you know it's a function, right? So what we're going to do is call it a function. It is a function, so we're going to call it a function. We're going to rewrite this as, instead of y equals, we're going to say f of x equals x plus 3. We didn't do anything special to it at all. We just said, hey, if it's a function, let's call it a function. Y and f of x mean the same thing. It's that easy. If it's a function, call it a function. And the independent variable we're using is x, so it's f of x, okay? Okay, easy. Now, example 2, f of 0. That's my input. It's like a question. This is like asking a question. It's saying plug in 0. That's really what this says. F of 0 means really plug in 0. But I don't want to write plug in 0. F of 0 just means, well, f of 0 just means 0 squared plus 6 times 0 minus 10. It just means put 0 in for every x. Now the f of 0 is like the question. Let's say, okay, f of 0 is what? F of 0, this is like the question. We're going to say f of 0 is equal to negative 10. As a point, because this is graphing, right? As a point, because this is really graphing, we have a point 0, negative 10. It's the same thing as a point. We plugged in 0 for an x, and we got a corresponding y value of negative 10. Okay, f of 2, same thing. It's a question. It says plug in 2. So, all right, I can do that. F of 2 is equal to 2 squared plus 6 times 2 minus 10. That's all we're going to do. It's a question. So it says f of 2 is what? If I plug in 2, f of 2 is equal to 4 plus 12 minus 10. 16 minus 10 is 6, right? F of 2 is 6. So that's the same thing. As a point, we can describe that point as 2, 6. We plug in 2, we get an answer of 6. X, Y, right? We plug in 2, we get an answer of 6. And the same thing with the last one. F of negative 2, plug in negative 2. Let's see what that is. So we'll say, all right, f of negative 2 is equal to my negative 2 squared plus my 6 times negative 2 minus 10. Oh, I could really squeeze that in. I'm almost off page. Okay, squeeze it in. So f of negative 2. So I plugged in negative 2. That's all I'm going to do. Now be careful. Negative 2 squared, negative times a negative. Negative 2 squared, negative times negative is a positive 4 minus 12 minus 10. Negative 18, I think. I just checked, but I think it's negative 18. 4 minus 12 minus 10. What do you know? F of negative 2 is equal to negative 18. Okay, now it says, what is the domain and range? So the domain is the x value, right? And the range is the y value. So in this example, our domain happens to be this set 0. Yeah. 0, 2, and negative 2. Now it's kind of nice to have it in order, but that's what x value, right? X value is 0, 2, and negative 2, right? Oh, better yet in order, it might look better as negative 2, 0, and 2. Same answer. If you don't put it in order, I won't lose sleep over it. It's okay, but it's better to have it in order, right? That's the domain. What's the range? The y values, right? So my range is going to be negative 10, 6, and negative 18, because that's a y value, right? Oh, I might rewrite it in order. If you don't rewrite it in order, it's okay, but I like it in order. So I might rewrite it as a negative 18, negative 10, and 6, right? Domain's the x values, range is the y values. That's what I did, okay? Now, in example 3, easy. Easy. It is easy. This is my x value, right? So I'm going to find negative 3 on my x. It's right there. The answer is its y value, which is 1. I'll do it again. F of negative 3. Here's my x axis. So I'm going to go back to 1, 2, 3 on the x. Its answer is its corresponding y value, which is a height of 1. F of 0. Find 0 for x. The answer is its y value, which is 2. See how easy that is? Okay. F of 1. Find 1 on the x value. The answer is the corresponding y value, which is 2. F of 2. Find 2 on the x value right there. The answer is the corresponding y value, which is its height, which is 1. Easy, right? Okay, ready to turn the page? Alright, example 4. So the diagram shows ages of women and their maximum heart rate. Okay, so if you were to go out and run your guts out, your heart rate's going to jack up, right? The younger you are, the faster your heart can pump. Honestly, you can go. Some of us old people, even though we're still in shape, our maximum heart rate starts to slow down. It's kind of a bummer, but it's the way it is, okay? So let's take a look at this. So at age 0, we should put a graph at 209. So now what I want to do is probably try and get a graph that makes sense on this. So I've got to go from 209 to 181, so 181. So I'm going to do this little squishy thing. You guys ever seen this squishy thing here? You ever seen a squishy thing? Let's start at 180. So my squishy things means from 0 to here is 180. I just compressed all that, right? Because I don't need that information, right? These numbers gets it up there, right? So I just squish from 0 because I don't need those numbers. So we need 0, 10, 20, 30, 40. I might go by 5s. Here's my 10. Oh, let me get a better pen so we can see this better. Hold on. Let me go 10. I'm going by 5s. 10, 20, 30, 40, 50, 60, 70, and 80. And I tell you, if you're 80 years old and you're still trying to get your maximum heart rate, it's probably a good way to be done. Probably shouldn't be running all out at 80. I don't know. So let's do a scatter plot. So if I go 180, how about, let's see, 190. We'll go 200. So I have a 210 here, and that should do it, okay? So, let's do a dot to dot. So, let's see, a scatter plot 0 and 209. 209 is about there, okay? Right? Age 10, 202. So I'm going to estimate 202 to be probably right about there. 20, I'm going to go 195, which is there. 30, we'll go 188, about. there. 40, 181. It's about there, okay? And I'm going to just draw my graph, okay? How's that? So far so good? Kind of missed a point. It was a little sloppy. It's okay. What's our independent variable? What's our independent variable? Age. Right? Age. What's our dependent variable? Heart rate. Heart rate, right? Find the equation for this function and function notation. So I'm going to do this. I'm going to go, my age is my independent, so I'm going to go h of a. You okay with that? H of a. Heart rate with respect to age, okay? So if I need an equation, what I'd like to know is how much do I drop? It seems like I drop from 209 to 202, so it seems like I drop 7 for every 10, right? So that's like a -7 for every 10. You okay with that? I dropped 7 heartbeats for every 10 years age, right? Plus, well, if my age was 0, what would be this number here? If my age was 0, what would this number be here? Actually 209 to be exact. But sure, yeah, that's exactly right. 209, okay? So is this a function? Heck yeah, that's a function. It's a linear function, okay? So now, use your equation to find the maximum heart rate of 55, okay? So, if it were me, pretty much 55, what's my maximum heart rate? So we plug it in. We're going to go for Mr. Davies, h of 55. So the h of 55 is like asking the question. H of 55 says, okay, find the heart rate of 55. It's the question. Now the answer is going to be plugging it in. It's going to be equal to -7/10 times 55 plus 209. All right. Use my calculator. Can you see my calculator? Yeah. So we'll go -7/10 times 55 plus 209. And I get about 170.5 beats per minute, which is pretty close to what my max is. And I'm in shape too. All right. Capiche? Easy? Thumbs up?